45 years ago, two small machines built by human hands lifted off from our planet and began the longest journey ever attempted by anything humanity had ever created. They were called Voyager 1 and Voyager 2, twin explorers designed to travel beyond every known world and show us what no human eye had ever seen. Inside their metal frames was more than technology. They carried our curiosity, our questions, and a silent message that we were ready to explore the unknown. Their mission was simple to describe, but almost impossible to imagine. They would cross the vast darkness of space, visiting the giant planets and continuing outward until they reached the edge of the sun's influence. No one could predict what they would find. Scientists hoped for clearer pictures of Jupiter's clouds or Saturn's rings, but what came back would change our understanding of the solar system forever. Through their lenses, we would see volcanic worlds, oceans hidden beneath ice, and storms larger than Earth itself. We would witness the solar system as it truly was, alive, dynamic, and filled with surprises that no telescope on Earth could reveal. The story of Voyager became more than a mission. It became a statement of who we are, a species driven to see what lies beyond the horizon. In the late summer of 1977, the world watched as Voyager 2 launched first, followed a few weeks later by its identical twin. They rose through the Florida sky like silver arrows aimed at the stars. Each spacecraft was about the size of a small car, covered in antennas, cameras, and long metallic arms that carried delicate instruments. They were powered not by sunlight, which would soon become too weak, but by small nuclear generators that would keep them alive in the deep cold of space for decades. Scientists had timed the mission perfectly. Once every 176 years, the outer planets line up in such a way that a single spacecraft can visit them all, using the gravity of each world to slingshot toward the next. It was a chance that would not come again in our lifetimes. The Voyagers would take that path, moving from Jupiter to Saturn, then farther still to Uranus and Neptune. Beyond those worlds lay only the darkness between the stars. When the final stage of the rocket fired, the last connection to Earth was broken. Within minutes, both Voyagers had left the atmosphere and entered the great silence of space. Behind them, the blue world they came from grew smaller until it was just a bright star among billions. As they drifted away, the sun began to fade. Its warmth weakened, and the golden light turned pale against the endless black. Every hour their radio signals took longer to reach home. What started as a few minutes soon became hours. Commands sent from Earth crawled through space at the speed of light, and what returned were faint whispers carrying data, numbers, and images. Engineers at NASA's Deep Space Network strained to hear those signals, using massive antennas spread across the world to keep contact with the tiny travelers. The first images Voyager sent were of Earth and its moon, a delicate pair suspended together in the emptiness. It was a simple photograph, but it changed everything. For the first time, humanity saw itself from the outside. A single fragile planet wrapped in clouds and water, alone in the dark. That image became a mirror, reminding us how small we truly are, yet how far we could reach. As the Voyagers left Mars behind and entered the outer solar system, they crossed into territory no spacecraft had ever explored. Out there, sunlight was weak and cold. The warmth that powered missions near Earth could no longer help. The nuclear generators inside each Voyager provided a steady heartbeat of electricity, keeping the instruments alive as the temperature dropped hundreds of degrees below zero. Every reading they collected, every particle, every magnetic measurement, was a note in the song of the solar system. Through them, scientists could finally hear the wind of the sun itself, a river of charged particles flowing through space. Voyager was tasting the unseen world beyond the planets. For the first time, we were listening to the heartbeat of our own star from a distance of hundreds of millions of kilometers. Then, after more than a year of travel, Voyager 1 reached the kingdom of Jupiter. The giant planet filled its cameras with swirling colors and vast shadows. Storms the size of continents spun across its surface, lightning flashing in the depths of its clouds. Even before the spacecraft arrived, Jupiter had fascinated astronomers for centuries, but no telescope had ever shown it like this. The images revealed a living, breathing world of motion and energy, a place so immense that Earth could disappear inside it without a trace. As the spacecraft approached, scientists around the world stopped what they were doing to watch the first transmissions. The data arrived slowly, line by line, each gray band building into a picture. And when the full image appeared, it left even the most experienced scientists silent. They were staring into the face of another world. Jupiter was more than they had imagined. It was a planet of colors and chaos, a place of impossible storms and magnetic fields, strong enough to shatter electronics. Yet it was beautiful. The clouds moved like waves in a cosmic ocean, painted with red, white, and gold. The Great Red Spot, a storm larger than Earth, turned slowly in the darkness, its shape unchanged for centuries. The Voyagers had arrived at their first destination, and what they found would not only explain the nature of Jupiter, but also reveal how planets across the galaxy might work. This was only the beginning. Ahead lay moons that would erupt with volcanic fire, icy worlds that hid oceans beneath their crust, and rings made of frozen light spinning through the black. Each discovery would bring new questions, and each question would lead the Voyagers farther from home. But even then, before any of those revelations, the mission had already achieved something extraordinary. It had proven that the human spirit could reach across billions of kilometers and still find meaning in the silence of space. Every signal returning from Voyager was a heartbeat, a quiet reminder that curiosity is the most powerful force we have. These two machines were not just explorers. They were storytellers, carrying the tale of our species into the infinite dark, where their voices would continue long after ours fade. When Voyager 1 reached Jupiter in March of 1979, the world waited. It was the first time a spacecraft had approached the largest planet in our solar system so closely, and no one knew what it would see. For centuries, astronomers had watched the giant through their telescopes, tracing its colored bands and the strange red mark that never disappeared. They called it the Great Red Spot. But beyond its color and shape, almost nothing was certain. As the first images from Voyager began to arrive, scientists stared in disbelief. The storm was not just a circle of color drifting in the clouds. It was a living hurricane so large that two Earths could fit inside it with room to spare. Its winds tore through the upper atmosphere at nearly 400 miles per hour, faster than any storm ever measured on our planet. What had looked calm and distant through telescopes was now revealed as a raging world of thunder and motion. The color that gave the storm its name came from chemicals dredged up from deep within the planet's atmosphere. Phosphorus and sulfur compounds mixed and churned until they formed the deep red clouds that gave the storm its eerie glow. Voyager's instruments detected that the Great Red Spot was colder than the air around it, which meant it was not a typical storm at all, but a massive high-pressure system, a kind of atmospheric mountain rising above Jupiter's cloud tops. Hurricanes on Earth weaken and die when they pass over land or cool water, but Jupiter has no land to stop them and no oceans to drain their energy. Its storms can last not for days or weeks, but for centuries. The Great Red Spot had already been spinning since before the first telescopes were built. Voyager showed that it rotated once every 6 Earth days, endlessly fueled by the heat rising from the planet's core and by Jupiter's rapid 10-hour rotation. It was like a colossal engine that never stopped turning. As the cameras moved closer, new details appeared inside the storm's walls. Smaller eddies and whirlpools circled its edges like predators swimming beside a whale. Some were absorbed into the main vortex, others broke apart and vanished. The storm was not still for a moment. It breathed and evolved, pulling new clouds into its spiraling form while shedding old ones at the edges. The eye of the storm alone stretched 12,000 miles across, large enough to swallow our moon with ease. But amid this violence, Voyager found something unexpected. The storm, for all its size and fury, was slowly shrinking. By comparing the new data to photographs taken decades earlier, scientists discovered that the Great Red Spot had been nearly twice as large a century ago. No one knew why it was fading, But the discovery suggested that even on a planet of storms, nothing lasts forever. One day, perhaps centuries from now, the storm that had fascinated humanity for hundreds of years might finally dissolve into Jupiter's atmosphere. The discoveries did not stop with the storm. As Voyager moved through Jupiter's immense magnetic field, its instruments began to register a torrent of radiation unlike anything ever measured. The planet's magnetic field was 20,000 times stronger than Earth's, trapping charged particles in belts of energy that circled the planet like invisible rings of fire. These radiation belts were so intense that they could destroy spacecraft electronics within minutes, if not carefully shielded. They were also deadly. A human exposed to that environment would receive a lethal dose of radiation in less than a second. Voyager's cameras even showed how the radiation interacted with the planet's moons, stripping away their surfaces and painting them with electric energy. Scientists learned that the radiation around Jupiter was being fed by its moon Io, which constantly erupted with volcanic plumes that hurled sulfur and oxygen into space. These gases were trapped by Jupiter's magnetic field, ionized, and accelerated into streams of plasma that raced around the planet at nearly the speed of light. Jupiter, it turned out, was not only the largest planet in the solar system, it was also a natural particle accelerator, a cosmic engine hurling charged matter through space with unimaginable power. Despite the danger, Voyager continued to send home data and images, each one more extraordinary than the last. The photographs showed clouds folding over one another like waves on an ocean made of gas. Lightning flashed deep inside the storms, illuminating the dark side of the planet. The patterns of light and shadow created the illusion of motion, even in still pictures, a reminder that Jupiter's atmosphere was alive, constantly reshaping itself. The scale of everything defied imagination. A single band of clouds that seemed thin from a distance was taller than the highest mountains on Earth. Scientists began to see Jupiter not as a failed star, as it had once been called, but as a world with its own form of weather and energy, an entire system powered by forces beyond anything found on our planet. It produced more heat than it received from the sun, releasing the leftover energy of its formation. That internal heat drove the endless storms and fed the great red spot's power. Every new discovery from Voyager forced scientists to rethink what they thought they knew about planets. Until then, the solar system had been seen as a quiet family of worlds slowly circling the sun. Voyager revealed it as a dynamic, violent arena filled with motion, magnetism, and extremes of energy. The Great Red Spot was not an exception. It was proof that nature could build phenomena far beyond anything on Earth. After weeks of observation, Voyager turned its cameras away from Jupiter's cloud tops and aimed them at the moons circling the giant. Each was a world of its own, and each would surprise scientists in ways that no one had predicted. But among them was one that changed everything we believed about how moons behaved. It was called Io, and what Voyager saw there seemed impossible. As Voyager 1 passed beyond the swirling storms of Jupiter, its cameras turned toward one of the planet's many moons, a small world named Io. From a distance, Io appeared like a dull yellow marble orbiting in the glow of Jupiter's clouds. But what Voyager was about to see would shake the foundations of planetary science. Navigation engineer Linda Morabito was examining one of the images sent back for navigation data when she noticed something odd rising above the moon's surface, a bright curved plume stretching hundreds of miles high. At first, Mission Control thought it was a trick of light, perhaps a background star, or a camera fault. But as more photographs arrived, the truth became undeniable. Io was erupting. The tiny moon was not dead and frozen like scientists had always assumed. It was alive with volcanic fire. Voyager's images revealed enormous fountains of molten rock exploding from the surface and shooting sulfur and gas hundreds of miles into space. Some plumes were so powerful that they escaped Io's gravity, completely creating vast rings of material that encircled Jupiter. It was the first time active volcanoes had ever been seen anywhere beyond Earth. 8 eruptions were visible during Voyager's first flyby alone. These were not slow lava flows like those in Hawaii. They were violent explosions releasing enough energy to rival nuclear weapons. Some plumes rose 300 miles into space before raining frozen sulfur back onto the surface. The landscape of Io looked like something out of a dream. Bright yellows, oranges, and reds painted its plains, created by sulfur compounds melted and cooled by the constant volcanic activity. The surface was scarred by lava lakes and calderas, but not a single impact crater could be found. The moon's face was constantly being rebuilt. Old features vanished beneath new flows, as if the entire world were being resurfaced again and again. Scientists were astonished. What could possibly be powering so much heat on a small moon that should have been frozen solid billions of years ago? The answer came from Jupiter itself. Io was caught in a gravitational tug-of-war between Jupiter and its neighboring moons, Europa and Ganymede. As it orbited, these immense bodies pulled on Io's interior, stretching and squeezing it like a stress ball. The friction from this endless tidal flexing generated heat, enough to melt rock and drive the volcanoes that Voyager had captured in such detail. This realization changed everything. Until that moment, no one had imagined that tidal forces could generate such immense internal heat. It meant that moons could be far more dynamic than previously believed. Io had become the most volcanically active world in the solar system, its entire surface constantly renewed by eruptions. Scientists began calling it a world in perpetual creation, a cosmic factory where mountains rose and fell within human lifetimes. As Voyager continued to study Io, it found that the moon's volcanic gases, sulfur and sulfur dioxide, were feeding Jupiter's immense magnetic field. The materials ejected into space became ionized and trapped by the planet's magnetosphere, forming a vast ring of plasma around Jupiter. Io was literally fueling the planet's magnetic engine. Every eruption added more material to this invisible torus, a river of charged particles moving at incredible speeds. Jupiter and Io were locked together in a violent electrical partnership, each shaping the other in ways no one had predicted. The surface of Io glowed faintly where volcanic heat escaped into the vacuum. Some of its lava lakes were larger than entire states on Earth, shimmering pools of molten rock thousands of degrees hot. Temperatures on Io's surface could melt copper. Every few months, massive eruptions would rearrange entire regions of the moon, burying old craters and forming new mountains. In just 4 months, the features captured by Voyager 1 had already changed by the time Voyager 2 arrived. No other world in the solar system transformed itself so quickly. Io's discovery forced scientists to abandon the idea that moons were cold, lifeless bodies orbiting their planets. It proved that even small worlds could possess energy, heat, and geological activity. It also suggested that similar processes might exist elsewhere in the universe. If tidal heating could keep Io molten, perhaps it could keep other moons warm enough to harbor liquid water, or even life. The idea was astonishing. One small moon had rewritten our understanding of how planets and moons evolve. But the surprises did not end there. Voyager's cameras soon turned toward another of Jupiter's satellites, a bright, icy world named Europa. From a distance it appeared smooth and calm, the complete opposite of Io's fiery chaos. But hidden beneath that frozen surface was a secret even more profound, one that would change the way scientists searched for life beyond Earth. When Voyager's cameras shifted toward Europa, the change in scenery was immediate. Gone were the fiery eruptions and molten plains of Io. In their place was a world of silence and light, an icy moon glowing like a frozen pearl against the black of space. From a distance, Europa seemed calm and unremarkable, its surface smooth and bright, reflecting the faint sunlight that reached Jupiter's orbit. But as the images sharpened, scientists realized they were looking at one of the most extraordinary places in the solar system. Instead of a cratered, ancient landscape like the moon, Europa's surface was almost spotless, marked only by thin lines and cracks stretching across the ice in every direction. It looked as if someone had taken a white marble and scratched it with a fine blade, creating a network of intersecting ridges and valleys. The patterns were too complex to be random. They hinted at something moving beneath the frozen crust, reshaping it over time. Voyager's instruments measured the light reflected from Europa's surface and confirmed what the images suggested. The moon was covered in pure water ice, but what astonished scientists most was what lay below that ice. Based on the patterns of cracks and the apparent lack of impact craters, researchers concluded that the surface was constantly being renewed. Something was melting and refreezing the ice from below, erasing the marks of ancient collisions. The only explanation was heat, internal warmth strong enough to maintain liquid water beneath the crust. Beneath 10 to 15 miles of solid ice, there appeared to be an ocean, a global sea stretching around the entire moon, containing more water than all the oceans on Earth combined. Tidal forces from Jupiter, the same that kept Io's volcanoes erupting, were likely kneading Europa's interior, generating enough heat to keep that vast ocean from freezing solid. For the first time, humanity realized that water, a fundamental ingredient for life, might exist far beyond the traditional boundaries of the sun's warmth. The discovery transformed the search for life itself. Life might not need sunlight, mild temperatures, or an Earth-like atmosphere. It could exist in the dark, hidden oceans of distant moons, feeding on chemical energy from the rocks below. As scientists studied the images more closely, they saw evidence that Europa's icy shell was not static. It shifted and moved, opening cracks that refroze into intricate patterns. Some regions looked like frozen rivers, where ice had broken apart and drifted before sealing again. The surface resembled pack ice near Earth's poles, constantly pushed and pulled by the waters below. It was as if the moon were breathing, its shell flexing under the gravitational rhythm of Jupiter's pull. This meant that the ocean beneath was not sealed off forever. Materials from the surface could sink into the depths, and heat and chemicals from the interior could rise to the ice above. That exchange of energy and matter made Europa's ocean an active environment, one that might support chemistry similar to the early Earth. The idea of life in that dark ocean was almost too large to grasp. No sunlight could reach those depths. The sea would be a place of eternal night, lit only by the faint glow of minerals and the slow dance of heat escaping from the rocky mantle below. But on Earth, scientists had already discovered life thriving in similar places, creatures living around hydrothermal vents deep in the oceans, surviving without sunlight by feeding on the minerals in the water. If such life could exist here, why not on Europa? Voyager's data gave no direct proof of life, but it gave humanity something just as important: possibility. The moon that once appeared lifeless had become a symbol of hope. Decades later, this single discovery would inspire entire missions dedicated to exploring Europa's hidden ocean. The contrast between Io and Europa could not have been greater. One a world of fire, the other of ice, yet both were shaped by the same invisible power: Jupiter's gravity. One world turned that energy into molten rock, the other into liquid water. Together they revealed that the universe was more inventive than anyone had dared to imagine. As Voyager continued its journey outward, leaving Jupiter's realm behind, it carried new questions that would guide generations of scientists. If heat could be created by gravity, and oceans could exist without sunlight, then how many other hidden seas might be waiting in the darkness of the outer planets? The next destination would offer more answers. Ahead lay Saturn, the planet that had mesmerized astronomers for centuries with its shimmering rings. No one knew what those rings truly were, or how they stayed so perfectly shaped. Voyager was about to find out, and what it discovered there would once again defy every expectation. When Voyager 1 approached Saturn in late 1980, the spacecraft was already a veteran traveler. It had survived Jupiter's immense radiation belts, witnessed volcanic eruptions on Io, and uncovered the hidden ocean of Europa. Now it was about to face one of the most mysterious and beautiful sights in the solar system. For centuries, Saturn's rings had appeared through telescopes as smooth, solid bands of light, like grooves etched around a perfect sphere. But as Voyager's cameras focused and began sending back the first close images, the illusion shattered. The rings were not solid at all. They were made of countless individual pieces, fragments of ice and rock ranging in size from dust grains to boulders as large as houses, each moving in its own orbit, forming a structure so vast and delicate that it defied understanding. What had seemed from Earth to be a few neat bands turned out to be thousands of narrow ringlets, each with its own brightness and motion. Some of the gaps between them were caused by tiny moons hidden inside the ring system, their gravity sweeping away particles and sculpting sharp edges like the grooves on a record. Voyager revealed that the entire structure was astonishingly thin compared to its width. The main rings stretched more than 170,000 miles across, yet they were no more than 30 feet thick in most places. If the planet and its rings were scaled down to the size of a football field, the rings would be thinner than a sheet of paper. The sunlight reflecting off those ice particles made them shine like powdered diamonds. They were pure, clean, and bright, remnants of something ancient and violent. Many scientists believed they were the remains of a moon or comet that had ventured too close to Saturn and been torn apart by its gravity long ago. The fragments then spread out and flattened into the elegant, shimmering structure that Voyager was now revealing in detail for the first time. But the most astonishing discovery was that the rings were alive with motion. Waves and ripples rippled through them like vibrations across water. Some regions appeared braided, where ringlets twisted around one another like strands of rope. Others contained dark spokes that rotated with the rings, appearing and disappearing in patterns no one could yet explain. Voyager's instruments detected that these ghostly shadows were caused by tiny particles charged by Saturn's magnetic field and lifted above the ring plane by electromagnetic forces. The rings were not just a collection of ice. They were a vast electrical and gravitational system interacting with the planet's magnetic field in ways that created waves, shadows, and currents. The spacecraft also discovered small moons within the ring system itself, shepherds that used their gravity to keep the particles confined. One such moon, Prometheus, orbited just inside Saturn's narrow F ring, while another, Pandora, circled just outside it. Together they acted like cosmic herders, keeping the ring from drifting apart. Whenever a particle strayed too far inward or outward, one of the moon's gravitational tugs would pull it back, maintaining balance in a delicate dance that had lasted for millions of years. Voyager's cameras captured kinks and knots forming in the F-ring as the shepherd moons passed nearby, twisting the icy stream like a living ribbon. For the scientists watching from Earth, it was hard to believe that such beauty could arise from simple physics. Yet every shimmering detail obeyed the laws of gravity, magnetism, and motion. What Voyager showed was that nature could produce patterns of breathtaking precision purely through the interaction of matter and force. The rings were not static ornaments. They were a dynamic, constantly changing environment. Particles collided, clumped together, and shattered apart again, a cycle that kept the rings forever young even as individual pieces were lost to time. Saturn itself was no less spectacular. Beneath its pastel bands of yellow and gold, Voyager found powerful winds blowing at hundreds of miles per hour. Near the North Pole, the cameras captured something no one had expected: a perfect six-sided storm pattern swirling around the pole, each side longer than the diameter of Earth. It looked almost artificial, a geometric hurricane formed by nature itself. The hexagon rotated slowly, its shape never breaking even as clouds and storms moved around it. Scientists would later learn that this pattern was caused by waves in Saturn's jet streams, locked into a stable, repeating motion that formed the polygon. But in 1980, it seemed like a message written in the clouds, proof that the universe could create order out of chaos. As Voyager moved past the rings and looked back, the sunlight caught the icy particles at just the right angle. The planet and its rings glowed with a soft halo, a sight that left even the mission team speechless. Saturn was more than a world. It was a masterpiece sculpted by gravity. Yet among the planet's dozens of moons, one stood out as something truly unique. It was called Titan, and it was larger than the planet Mercury. Wrapped in a thick orange haze, Titan's surface was completely hidden from view. No telescope on Earth had ever seen through its clouds. Voyager was about to reveal what no one had seen before: the atmosphere of another world. As Voyager 1 drew closer to Saturn, its instruments locked onto the planet's largest moon. Titan had long been a mystery. Through telescopes, it appeared as a dim orange sphere surrounded by haze, its surface completely hidden beneath a thick atmosphere. No one had ever seen what lay below those clouds. Many scientists hoped Titan might resemble a young Earth, rich in the raw ingredients that once gave rise to life. As the spacecraft approached in November of 1980, those hopes grew stronger. Voyager's sensors detected something extraordinary. Titan's atmosphere was not thin and fragile like those of most moons. It was thick, dense, and heavy, stretching hundreds of miles above the surface. The pressure on the ground was more than 1.5 times that of Earth at sea level. This made Titan the only moon in the solar system with an atmosphere substantial enough to support weather. If a person could stand on its surface, they would not need a pressure suit. Only oxygen and warmth to survive the cold. But the air on Titan was nothing like Earth's. It was made mostly of nitrogen with a trace of methane and other complex hydrocarbons. Sunlight, weak and distant at Saturn's orbit, broke those molecules apart high in the atmosphere. The fragments reassembled into heavier organic compounds that drifted down through the haze, coating the surface in orange and brown particles. It was as if the sky were slowly snowing chemicals that could one day form the building blocks of life. Voyager's cameras tried to pierce the haze, but the thick clouds refused to let light through. No mountains, rivers, or plains could be seen. Still, the instruments revealed clues about what might lie below. Temperature readings suggested the surface was far colder than anywhere on Earth, around 300 degrees below 0 Fahrenheit. Yet even in that frigid environment, methane could exist in liquid form, playing the same role that water plays on Earth. Scientists began to realize that Titan might have lakes, rivers, and rainfall, not of water, but of liquid methane and ethane. In Titan's slow orbit around Saturn, sunlight barely reached the ground. But the moon's atmosphere created something remarkable: a cycle of weather. Methane evaporated, formed clouds, rained down, and collected again in lakes and seas. Voyager had found the only other place in the solar system where liquid flowed freely across a surface. It was a strange reflection of Earth, frozen and alien, yet governed by familiar rhythms. The possibilities fascinated scientists. Titan's air was thick enough that, in its low gravity, a person could strap wings to their arms and fly through the orange skies. Its dense haze shielded the surface from harmful radiation, allowing chemistry to develop undisturbed for millions of years. Some researchers began to wonder whether Titan might be a kind of time capsule, preserving conditions similar to those on early Earth before life began. As Voyager continued to gather data, its infrared sensors detected subtle variations in temperature that hinted at differences across Titan's surface. The equatorial regions appeared slightly warmer, perhaps covered in vast dunes of dark organic sand. The poles seemed colder and smoother, likely home to frozen lakes of methane and ethane. Titan was not a static world. It had weather, geography, and complex chemistry, all wrapped in a perpetual orange twilight. When the spacecraft finally moved past Titan, its instruments were still struggling to see through the haze. But what little data it captured was enough to ignite decades of curiosity. Titan had become one of the most intriguing worlds ever discovered. A frozen mirror of our own planet, where rivers of methane carved valleys and clouds of hydrocarbons painted the sky. Yet Saturn still held another surprise. Not far from Titan, another moon waited, smaller, brighter, and seemingly ordinary. It was called Enceladus, a frozen sphere barely 300 miles across. For centuries, astronomers had thought it was just an icy rock reflecting sunlight into space. But as Voyager 2 approached it in August 1981, something strange appeared. The moon's surface was almost pure white, gleaming brighter than any other object in the solar system. And unlike most small moons, it showed few impact craters. That meant the surface was young and constantly renewed, as though something were erasing its scars. Voyager's cameras captured ridges, valleys, and smooth plains that suggested geological activity. Then came the most astonishing discovery of all. Near the South Pole, Voyager detected plumes of vapor rising from long cracks in the ice. They stretched hundreds of miles into space, jets of water vapor mixed with ice particles and organic molecules. Enceladus was erupting. The moon's small size should have left it frozen solid, but it was warm inside. The same tidal forces that heated Io and Europa were at work here, though on a smaller scale. As Enceladus orbited Saturn, the planet's gravity flexed the moon's interior, generating heat through friction. Beneath the crust, an ocean of liquid water remained trapped under miles of ice. The vapor jets burst through cracks in the south polar region, venting that water into space where it froze instantly. Those frozen particles became part of Saturn's outermost ring, creating a delicate halo around the planet. It was a discovery no one had predicted. A tiny, seemingly insignificant moon had revealed one of the most promising environments for life beyond Earth. The plumes contained not only water but also salts and organic compounds, the essential ingredients of biology. Scientists realized that if a spacecraft could fly through one of those geysers, it could sample the ocean without ever landing. Enceladus had become a doorway to another possible ocean world, one hidden beneath a shell of ice. As Voyager left the Saturn system, the mission team knew they had seen something truly remarkable. Saturn's rings were no longer a mystery. Titan's atmosphere had revealed that weather could exist even in the outer solar system, and Enceladus had shown that liquid water, a key ingredient for life, might exist in places no one had ever imagined. But the journey was far from over. Ahead lay two more planets, distant, cold, and mysterious. No spacecraft had ever visited them. The next encounter would take Voyager into a realm of ice giants, where sunlight faded to a faint glow, and the strange tilted world of Uranus awaited. By the time Voyager 2 reached Uranus in January of 1986, it had already traveled nearly 2 billion miles from Earth. The sunlight was now so weak that the planet received only a fraction of the warmth that reaches our world. To the human eye, Uranus looked calm, quiet, and featureless, a pale green sphere hanging in darkness. But as Voyager began its close approach, it revealed that beneath this calm appearance lay one of the strangest and most unpredictable worlds ever seen. Uranus was not like any other planet. It rolled around the sun on its side, tilted by almost 90 degrees. Its poles pointed nearly where other planets' equators would be. No one knew why it was so misaligned, but scientists suspected that long ago a massive collision had knocked it over, freezing its seasons into extreme patterns. Each pole would spend 42 years in sunlight, then 42 years in night. Voyager's instruments confirmed that the planet's magnetic field was also tilted and offset far from its center, creating an unstable bubble of magnetism that twisted and shifted with every rotation. The planet's pale blue-green color came from methane gas in its upper atmosphere, which absorbed red light and reflected the blue. But when Voyager looked closer, it found subtle streaks and faint clouds hidden within the haze. Using infrared sensors, it detected winds racing at nearly 600 miles per hour, fast enough to circle Earth in a single day. What had appeared still and empty was actually a world of violent, invisible motion. Voyager's cameras also captured 11 new moons orbiting Uranus, adding to the 5 that had been known since the 18th century. These small worlds were scarred and irregular, shaped by collisions over billions of years. One of them, Miranda, left scientists stunned. Its surface looked shattered, with cliffs rising 12 miles high and enormous canyons cutting across its face. It appeared as if the moon had been broken apart and then reassembled in pieces, its terrain stitched together from fragments of ancient worlds. Some of its valleys were so deep that if you stood at the bottom, the horizon would curve above your head. Miranda's strange surface hinted that powerful forces, perhaps tidal heating or ancient impacts, had once reshaped it completely. Uranus itself radiated almost no internal heat, a mystery that still puzzles scientists today. Every other giant planet releases more energy than it receives from the sun, But Uranus seemed quiet, as if something inside it had gone dormant. Still, its tilted axis and chaotic magnetic field made it one of the most unique places in the solar system. Voyager's flyby transformed our understanding of what an ice giant could be, revealing that even the coldest, most distant planets were far from lifeless. After its encounter with Uranus, Voyager 2 continued outward toward the final destination of its grand tour, the deep blue planet Neptune. This last world lay another billion miles beyond Uranus, nearly 3 billion miles from the Sun. At that distance, sunlight was barely bright enough to cast a shadow. Neptune was the outermost of the gas giants, a planet about the same size as Uranus, but far more active. When Voyager approached in the summer of 1989, it saw something unexpected. A huge dark storm swirling across the planet's surface, a mirror to Jupiter's great red spot but deep blue in color. Scientists called it the Great Dark Spot. Neptune's atmosphere was a place of extremes. Winds there reached speeds of more than 1,300 miles per hour, the fastest ever recorded in the solar system. Despite the weak sunlight, the planet's internal heat drove immense storms that formed and vanished in a matter of years. Clouds of frozen methane and ammonia crystals drifted through its upper layers, casting long shadows in the faint light. Voyager's cameras watched lightning flash within the clouds, illuminating the planet's deep blue haze. It was a world of powerful contrasts, a frozen giant that somehow generated more heat than it received, a place of cold sunlight and roaring winds. Voyager also revealed Neptune's faint ring system, something no telescope on Earth had ever confirmed. The rings were thin, dusty arcs rather than continuous bands, shaped by the gravity of small nearby moons. Among those moons was Triton, the most remarkable of them all. Larger than Pluto, Triton orbited Neptune in the opposite direction of the planet's rotation, a clue that it was once a wandering object captured by Neptune's gravity. Its surface was pale and pink, coated with frozen nitrogen and methane. As Voyager drew closer, it saw geysers erupting from beneath the ice, shooting plumes of gas and dust 8 miles high. Triton was alive, reshaping its surface even in the freezing darkness of the outer solar system. Beneath its crust, scientists suspected, there might be a hidden ocean warmed by the same tidal forces that stirred the interiors of Europa and Enceladus. As Voyager 2 flew past Neptune, it became the most distant emissary of humankind. No spacecraft had ever traveled so far. Its cameras turned back one last time to capture the full view of the planet and its faint rings. Then the spacecraft began its long journey into the unknown, leaving the realm of the planets behind forever. From Jupiter's storms to Neptune's winds, the Voyagers had shown that the solar system was not a collection of silent rocks, but a living, dynamic place filled with oceans, volcanoes, and endless motion. They had completed their grand tour, but their journey was not over. Ahead of them stretched the edge of the Sun's influence, the vast invisible frontier known as the heliopause, where the solar wind gives way to the winds of interstellar space. That would be their next destination, and what they found there would mark a first for all of humanity. As the years passed and the planets fell behind, Voyager 1 and Voyager 2 entered a region of space that no spacecraft had ever reached before. The light from the Sun grew fainter until it was just another star among billions. Behind them lay the worlds they had revealed: Jupiter's storms, Saturn's rings, Titan's haze, Neptune's blue winds, and ahead stretched an infinite darkness, a silence deeper than anything humanity had ever known. Their next destination was not another planet, but the invisible boundary where our Sun's power ends, the frontier between the solar system and the galaxy beyond. Every second, the Sun emits a stream of charged particles known as the solar wind. This wind blows outward in all directions, creating a vast bubble of magnetic energy that surrounds the solar system. That bubble is called the heliosphere, and it acts as a shield, protecting our planets from much of the radiation and cosmic particles that fill interstellar space. But the farther the Voyagers traveled, the weaker that wind became. Somewhere ahead lay the place where it would fade completely: the heliopause. the edge of the sun's reach. Voyager's instruments could not see this boundary directly, but they could hear its approach. The stream of charged particles began to slow, and the magnetic field around the spacecraft started to change direction. Cosmic rays from outside the solar system grew stronger, sneaking through the thinning wall of the sun's protection. The spacecraft was crossing a frontier no human had ever experienced. On Earth, scientists waited for each new transmission, trying to understand what the data meant. Signals now took more than 16 hours to reach home. What returned were faint whispers of information, the last steady pulse of our technology moving through the void. In August of 2012, Voyager 1 sent back the measurements that confirmed what scientists had hoped for decades. It had crossed the heliopause. The solar wind had vanished. The surrounding plasma now vibrated with frequencies belonging to the galaxy itself. Humanity had left the solar system. For the first time in history, something built on Earth was flying through interstellar space. Even in that endless dark, the spacecraft continued to function. Its nuclear power source still provided enough energy for its instruments, though each year its strength faded a little more. Voyager 2 followed 6 years later, crossing the same invisible border in 2018. Both spacecraft were now traveling through the space between the stars, still carrying the voice of Earth with them. They were far beyond the orbit of Pluto, far beyond the Kuiper Belt where icy bodies drift like forgotten debris from the birth of the planets. Out there, sunlight was so weak that the sky no longer glowed. The temperature had fallen close to absolute zero. Yet the Voyagers kept transmitting. Their antennas, larger than a human house, continued to send faint radio signals across more than 15 billion miles of space. The strength of those signals was weaker than the light from a watch battery seen from another world. Yet the deep space network on Earth could still catch them. Inside Mission Control, engineers monitored each new packet of data with reverence. Every number, every vibration, every change in cosmic radiation told them something new about the space between the stars. Voyager had become not just a spacecraft, but an ambassador, a messenger for an entire planet. What it carried inside would outlive even the power that kept it running. Each Voyager held a golden record, an actual disc coated in gold, engraved with sounds and images chosen to represent life on Earth. There were greetings in 55 languages, the songs of birds, the laughter of children, the roar of the ocean, and the music of Bach, Beethoven, and Chuck Berry. Diagrams showed the location of our sun among nearby stars and instructions on how to play the record. It was humanity's time capsule drifting into eternity, waiting for whoever or whatever might someday find it. That golden record was the idea of astronomer Carl Sagan and his team, who wanted the spacecraft to carry more than instruments. They wanted it to carry meaning. If another civilization ever intercepted Voyager, the record would tell them that life once existed here, that a species called humanity had reached out into the dark to say hello. Even if no one ever finds it, the gesture itself was profound. It meant that amid the vast emptiness of space, we had dared to introduce ourselves. Voyager's journey was never about finding life or reaching another star. It was about understanding the space we inhabit, about seeing our home from the outside. Decades after their launch, both spacecraft still drift onward, traveling 1 million miles each day. Long after their power fades and their signals fall silent, they will continue moving, carrying that golden record as their only voice. In 1 billion years, when the Earth itself may be gone, Voyager will still be out there, a silent witness to the civilization that built it. Looking back, the mission that began as a brief planetary tour became something much larger. It showed us that our solar system is alive, unpredictable, and beautiful beyond imagination. It proved that small machines powered by curiosity could reach the edge of the sun's domain and keep going. And it reminded us of something greater, that the universe is not empty, but waiting. And that exploration is part of what it means to be human. The Voyagers are still out there now, far beyond the reach of the sun, gliding through the endless night. Their antennas still point toward home, though the light from Earth has long since vanished from their view. Somewhere between the stars, 2 small messengers carry our story. moving forever through the quiet sea of the galaxy. They drift now through a silence so deep that it cannot be imagined. Twin explorers moving farther from home than anything humanity has ever made. The faint glow of the sun has become just another star behind them, no brighter than countless others scattered across the sky. Yet they still travel onward, pulled by no gravity, guided by no hand, their course set forever toward the unknown. Voyager 1 and Voyager 2, born of metal and thought, are now timeless. Somewhere in that distance, beyond the warmth of our star, they continue to send whispers home. Each signal takes more than 20 hours to arrive, carrying the faint heartbeat of their instruments. The data no longer speaks of planets or moons, but of the quiet between them, the thin plasma that fills the galaxy. These messages are small, yet they mean everything, because they remind us that we once reached beyond what we could see. When engineers first built the Voyagers, no one expected them to last more than a few years. They were designed for brief flybys, to capture images, send data, and fade into history. But they refused to die. Decade after decade, they kept going, their systems slowly aging but never surrendering. In their persistence, they became something more than machines. They became a reflection of humanity's own endurance, our unwillingness to stop searching. The golden records they carry are now drifting farther away than any message ever sent. Each contains greetings from children who are now grown, music from civilizations that will one day fade, and images of a planet that may not always exist as it does now. They carry the story of rivers, laughter, mountains, and life, the story of us. If someday, millions of years from now, another intelligence finds them and learns to read those symbols, they will know that we were here, and that we cared enough to send our voice into the dark. But perhaps the most powerful message of all was not in the record or the data, but in what the Voyagers taught us about ourselves. When the spacecraft turned their cameras back toward Earth for one final photograph, they captured a single, fragile dot suspended in a beam of sunlight. That dot was everything we know, every person, every story, every war, and every act of kindness, all contained within a pale blue point no bigger than a pixel. That image became one of the most humbling visions in human history. It reminded us that our home, so vast to us, is just a tiny island in a boundless sea. Voyager's journey showed that exploration is not only about discovery, it is about perspective. It taught us that the universe is immense, but it also taught us that being small does not mean being insignificant. Those two little machines, built by human hands and powered by curiosity, became our eyes in the dark. Through them, we saw that even the farthest places are connected to us, that our story is part of something larger and infinite. Long after their power fades, after their voices fall silent, they will still drift among the stars. The atoms in their hulls will continue their endless motion through the galaxy, orbiting its center once every few 100 million years. In that sense, Voyager will outlast us. It will outlast the continents, the languages, and perhaps even the memory of the species that built it. And still, it will carry the traces of who we were. When humanity first looked up at the night sky, we saw only mystery. Voyager turned that mystery into knowledge and wonder. It revealed that the universe is not a void but a living system, filled with storms, oceans, and the raw ingredients of life. It showed us that our curiosity could cross billions of miles, that our desire to understand is stronger than the limits of time or distance. Now, as they travel through interstellar space, the Voyagers are not just machines. They are symbols of hope. They remind us that even a small spark of curiosity can light the darkness, that exploration is not a luxury, but a part of who we are. They whisper that the story of humanity is still being written, and that somewhere, far beyond the last ray of sunlight, our voice continues to travel. And so the Voyagers go on, eternal travelers carrying the memory of a blue planet. They move through the silent ocean between the stars, where no horizon marks the end of their path. They will never stop, because there is nothing to stop them. They will drift forever, bearing a simple message from their creators, a message written in every heartbeat and every question that ever looked toward the night sky. We were here. we saw, we wondered, and we reached for the stars. Even now, as the decades have passed and the Earth that launched them has changed beyond recognition, the Voyagers continue their quiet journey through the dark. Nations have risen and fallen, generations have lived entire lives, and yet those small silver messengers still move steadily outward, untouched by time. Their systems are old, their power fading, but their mission endures. They are still doing what they were built to do: listen, measure, and remember. Back home, the signals they send are so faint that only the largest antennas on Earth can hear them. It takes patience, hours of tracking, and precise coordination to catch each whisper of data from 15 billion miles away. When the messages finally arrive, they carry the soft rhythm of the galaxy itself, the vibrations of charged particles, the low hum of cosmic radiation, the signature of the space between the stars. For scientists, those tiny traces are treasure. They reveal how far the influence of our sun extends, how the magnetic field of our star merges with the vast field of the Milky Way. Voyager is teaching us what it means to leave home, to step beyond the shelter of our star, into the true wilderness of space. Each time a signal returns, it reminds us that distance does not erase connection. Across billions of kilometers, the link still exists, a thin thread of radio waves stretched between a small planet and its distant creation. That thread represents the reach of human curiosity, the invisible bond between the minds that built Voyager and the machine that continues their dream. In a sense, every time Voyager speaks, it says that we are still here, still listening, still willing to understand. As we look at the night sky today, we know that both spacecraft have traveled so far that the sun is no longer the center of their world. The constellations themselves are changing from their viewpoint. Someday, perhaps tens of thousands of years from now, they will pass near another star, drifting silently past alien suns that will never know they were visited. The golden records they carry may survive long after everything else from our time has vanished. To any beings who might someday find them, they will speak of a civilization that looked outward with hope, a species that refused to remain confined to its cradle. The legacy of Voyager is not just its discoveries, but what it revealed about the human spirit. We are a species driven by questions. We build tools, send them into the dark, and wait for answers. Voyager's images, its sounds, its data, all of it reminds us that knowledge begins with wonder. It proved that even small steps taken with curiosity can lead to unimaginable horizons. Every generation that looks up now carries a piece of that story, a reminder that the universe is not out of reach but waiting to be explored. In classrooms and observatories, in documentaries and quiet conversations, Voyager continues to inspire. Children who were not yet born when it launched now study its journey as a lesson in perseverance and imagination. Artists, poets, and scientists alike see in it a symbol of endurance. A tiny human creation, crossing the endless sea of stars, still alive, still speaking. And someday, when both spacecraft finally fall silent, when their power fades and their antennas stop transmitting, they will continue their voyage through eternity. No matter how long they travel, they will always carry that message engraved in gold, a message older than language and larger than time. Hello. This is Earth. Long after our cities crumble and the oceans shift, those two machines will still glide between the stars. Their journey will continue long past memory, their golden records still whispering to the universe that life once bloomed around a small yellow sun. They will never find home again, but they will always belong to it. They are us, our curiosity, our hope, our voice set adrift. And somewhere in that endless night, between the echoes of galaxies, their faint signals may still be traveling, moving through the dark like a heartbeat. Each pulse carries a simple truth, that in the vast silence of the cosmos, something once dared to listen and to speak back. Voyager's journey is not only a story of exploration, it is the story of humanity itself. The story of a species that looked at the stars, refused to be afraid, and sent its voice into eternity. Would you like me to craft a short, documentary-style closing narration paragraph? The kind that ends the voiceover with emotional resonance, like the final 2 minutes of a film? It would summarize the message of the Voyagers and leave the audience in reflective silence.